Hello everybody, my name is Halo. In this video, I'm going to be walking through IPC using shared memory. Okay, so this is an operating systems lecture. I don't want to go with the details of all of this because when I try to do this or build all of this from scratch, it look very intimidating, but in reality, there's only two files here, something called the server and the client. And both of these files are very simple. So I just wanted to just read through this code instead of doing that one by one what this decode is. I don't want to overwhelm you guys. So I think this will be a better option for that. Okay, so let's just get into the what we are talking about here. What is IPC using shared memory? There is nothing. You're going to be using a server and a client. Okay, what we'll do is the server reads stuff from the shared memory. Okay, and the client writes stuff to the shared memory. That's it. And by shared memory, I mean nothing but a buffer. What you need to remember first, we need to import multiprocessing.shared memory because this is something that we're going to be using to demonstrate this particular process. Okay, that has a class called shared memory, and that class is what we're going to be using. And this class shared memory class is we're using it to create a SHM server. SHM nothing means shared memory. Okay, so we need to create a shared memory. Server side, we need to set the size. And client side, you just need the name. Okay, so in the this particular case where the shared memory, these are the three things you're going to do. Create equal to true means create this new shared memory. Okay, size of the shared memory followed by the name of the shared memory. This name you can give anything. Okay, so this import we already talked about, and from here this dot shared memory, these three conditions is there to create your shared memory server. Okay, whatever server object you're creating, that dot buff will give you the buffer. This buffer is what we'll use to read or write it. Okay, for the writing part, that is the server part, what we'll do is we will while true. Okay, we'll keep looping this infinitely because I'll run two different terminals and show you guys that this is what is happening. Okay, so server data will be nothing but bytes buffer. Okay, this line here, oh my god, it was so intimidating to me when I first read this. Let me just tell you what this means. Okay, buffer this to 100 is read the first 100 bytes of the buffer. That's it. And we're doing 100 here because we set the size to 100. Read the first of the buffer, and this will be bytes because this will be some encoded value. We take the bytes of this particular value and decode this back to UTF-8 so that we can read this. If you're decoding this from the server side to print stuff, that means the client side, when we are sending this data, we will go ahead and say encode this particular value. Okay, so that's why we're decoding in the server and printing this data. Okay, when you're doing with IPC using shared memory, there will be one person who sends the memory, one person who displays it. Okay, you can take that to be the server or the client, that is up to you. And in this particular case, we have actually taken that the server prints the data, the client sends the data. Okay, and that's it we're doing. We're just printing this. Finally, if the client says exit, we just close this particular server and unlink it. Okay, these two lines is by heart. That's it. Just close the server, this object that we're creating, and unlink the server. That's it. If you don't unlink it, next time we can't create a server with the same name. That's what I assume it is, because that's what an issue that I faced before. I don't remember, this was a long time back. Finally, we do time.sleep. Okay, now at the client side, look, let me just pull this up side by side so that you guys know that this is nothing basically. See, same code as the server only. In the server, you do time, multiprocessing the shared memory. Yeah, all of this is same. In the client side, instead of doing create is equal to true, all of that, size you don't need, just put the name of the shared memory. And then buffer will be the same thing only. This buffer and this buffer are the same values. Okay. So what now you need to do is you need to put a way where you're writing data into this particular buffer. And explaining that particular part, let me just close this now. See, server data, again this part right here. Right, server data is nothing but buffer of this 200 dot decode. This is the same thing that we discussed before. Then we need to input something. Okay, input data, some data that we need to send to the server. Okay, then that buffer, this part to 100 is equal to byte of /x00 into 100. What this means is we are saying the buffer size is 100 bytes, right? Every byte, set that to nil, clear the buffer. Okay, and whatever value you are putting as data, set that to the new buffer. If you don't clear the buffer, what will happen is, let's say initially the buffer has some word called animal, ANIMAL. There are 6 letters. Now if I put something as cat, and the first three letters I replace, because that is the size of the data, the new data that I'm providing. Now the buffer will be something like CAT, okay, at the same time MAL, because the animal data is not clear. So I will get an answer called catmal. That is something that I don't want. So whenever the user enters new data, just clear the buffer first, then encode this particular data at UTF-8 and set that particular value the message. Okay, this part right here is something that you need to by heart, and that took a long time for me to by heart as well, but it should be able to, you guys should be able to do it. Finally, if the data is exit, just set the buffer to exit, the first 4, then client, unlink the client and close the client as well. Okay, once you're doing all this, you can close the client again. This is not really required, but okay, that is up to you whether you do this or not. You can actually don't need any of this also. You can just go ahead and directly do Control C and close the terminal also if you're showing this as an output for your lab exam. But this is what I've done it. Okay, so this may be wrong. If you guys have better approaches, you can let me know down in the comments. So to demonstrate this, if you guys want to do it, you have to open your terminal, and you need 2 terminals. For that, you do something called split terminal and VS Code. You have 2 terminals. In the first terminal, what I'm going to do is I'm going to do Python and server, right? Server dot Python. Python 3 is what I have to use because this is Linux, right? Server is there. Now I have to go ahead and start the client. So Python 3 client dot. Okay. So see, the server says keeps what? Looping. Because we had a time.sleep, every 3 seconds it'll keep saying what the server is saying. That is, what is the data is there in the shared memory. Okay. Now let me just insert something sample data and wait for 3 seconds. The next time this reloads, you see server says sample data. That is, it is using that particular shared memory. Okay. If I, for example, now I want to reset it. Hi YouTube. So I will do something like this. The shared memory is now reset. You're saying the server says this, and the next time the server says something, it'll say whatever our stuff is there in the shared memory. You can do anything. So when you're demonstrating this for your particular case, you just type anything here and then tell them that whatever that is here is sent back to the server. Then they'll ask you one thing: can the server do something except directly printing the stuff that the client is sending them? You say yes, I can do it. All I'll do is type exit. If I type exit, you see it breaks here, and here you get a warning. Okay, and this error right here is something that I have not been able to decode. I thought there was something to do with unlinking. That is why I wrote some close also that's there, but this thing is something that I won't see. There's some warning here with the name of the shared memory that we're using here, but that shouldn't be a problem for you. If you guys know how to solve this, let me know down in the comments as well. But this should be enough to demonstrate what inter-process communication is there using shared memory. I hope this video helped you. If it did, hit that like button. If you guys have any questions, let me know down in the comments. I'll try my best to answer them. If you guys are able to answer these questions yourself, you guys can help each other down in the comments as well. Again, I'll see you in another video. Thank you so much for watching. Bye.